Welcome to the course module of Communication Engineering. And in this video, we are going to solve one numerical problem based on the concepts that we have discussed in my previous lectures. So in my previous lectures, I have already discussed about the Gaussian random variable, and I have also discussed about the various concept of probability density function and probability theories. Okay. So that we have to use here, and then we have to solve this particular problem. So let's try to solve this problem. The statement of this particular problem is the noise voltage in an electric circuit can be modeled as Gaussian random variable with mean equals to 0 and variance equals to 10 to the power minus 8. So here in the problem itself, it is given that the noise voltage which is available in an electric circuit is actually being modeled as a Gaussian random variable. Okay, so it is having its mean value equals to 0 and its variance given as equals to 10 to the power minus 8. So now we have to find out these probabilities, right? So the first problem is what is the probability that the value of the noise exceeds the level 10 to the power minus 4 volts. Then second, we have to find out this probability. What is the probability that the value of noise exceeds this particular voltage 4 into 10 to the power minus 4 volt. Then we have to find out this particular probability that the noise voltage will be in between minus 2 into 10 to the power minus 4 to 10 to the power minus 4. Okay, so these are the different probabilities, and in the last point we have to find out this particular probability. The noise, given that the value of noise is positive, then what is the probability that it exceeds 10 to the power minus 4? So these are the problems that we have to find out. And here certain Q function values are mentioned. Okay, Q1 value is given, Q2 value is given, Q3 and Q4. So these are the certain Q functions values are actually mentioned. So now try to solve this problem. Okay, so as I have already explained you about the Gaussian random variable. So if we have the Gaussian random variable, so let's assume that the noise voltage is actually being represented by capital X, the random variable capital X. Okay, so we know that for the random variable capital X, if it is having a Gaussian random distribution, in that case, we can have the probability a Gaussian probability density function is actually given by this particular expression. I have already discussed this expression, okay, in my previous lecture, right? So this is the expression for a general expression in which we are having a mean equals to m and variance equals to sigma square. Okay, so I have also discussed these probabilities, right? So what is the probability that this variable x, this random variable x, will be less than equals to x? So this probability for a general Gaussian PDF can be calculated by using this formula 1 minus q x minus m divided by sigma, right? So this is the x, this x is a particular value of x for which we have to calculate the probability, okay? And m is your mean value, and this sigma is your standard deviation, right? So I also discussed about this particular probability. What is the probability that this p will be x greater than x? So that can be calculated by using this equation, right? This particular formula. So this way we can calculate the various probabilities, right? So here, if you see, this is the Gaussian random variable PDF curve, okay, that I have already discussed. And since it is given that its mean is equals to 0, right? So it should be symmetrical around 0. Okay, so let us suppose that onto this x-axis, we are having the various values of your noise voltage x. Okay, so that noise voltage may be varying from somewhere to somewhere, right? So here that range is actually not mentioned, but here it is given, it is having the Gaussian distribution, right? And it is having 0 mean. So now the variance which is given is sigma square, right? So variance means it is sigma square value is given equals to 10 to the power minus 8. So now what we have to do is we have to find out these probabilities. So first, if you see, we have to find out what is the probability that the value of noise exceeds the value 10 to the power minus 4. So it is a positive value, okay, 10 to the power minus 4, right? So it will be a positive value. So somewhere here you may have 10 to the power minus 4, okay? So we have to find out what is the probability that this noise voltage X will be greater than this particular value. So now, if you want to find this probability, we can write this as what is the probability that this random variable X will be greater than 10 to the power minus 4. And this formula we can use, right? So here this formula to find out this particular probability is Q X minus M by sigma, right? So just you substitute this value of X, this small x is 10 to the power minus 4 minus M, right? So this M value is equals to 0, right? Because it is a Gaussian random variable with 0 mean. So this value we have to substitute, and again we have to substitute this value of sigma, right, which is a standard deviation. So sigma square is 10 to the power minus 8, so it will become sigma equals to 10 to the power minus 4, right? So that we can substitute. So this value will be coming out as Q1, and this Q1 value given here is 0.1586. So this will be the probability of getting this noise voltage to be greater than 10 to the power minus 4. Similarly, if you want to calculate what is the probability that the value of the noise exceeds this particular level, okay, 4 into 10 to the power minus 4. So just your small x value will become 4 into 10 to the power minus 4. And again, you have to substitute into this particular general formula, okay? So this is your general formula, right? So here you have to again substitute it. You will be getting this value equals to Q4. And this Q4 value is given over here. It is 0.00003167. So this will be the probability of finding this particular value X, which is exceeds this particular level. Now in the third problem, we have to find out what is the probability that the value of the noise will be will be in between -2 into 10 to the power minus 4 to 10 to the power minus 4. So let us say that here it is 10 to the power minus 4. This X value is 10 to the power minus 4. And here somewhere we are going to get this value equals to -2 into 10 to the power minus 4, okay? Because it is -2 to the power 2 into 10 to the power minus 4, it should be somewhere here, right? It will be somewhere here, because if it is, we are assuming 10 to the power minus 4, then this will be minus 10 to the power minus 4. So here somewhere it will be minus 2 into 10 to the power minus 4. So we have to find out what is the probability that this noise voltage will be in between this, okay, in this particular range. So how to find out that probability? So that probability we have to again write. So this probability we have to find out that this capital X will be in between this particular range, and that you can again find it out by writing this particular probability, okay? So what probability we can write here is, we can write what is the probability that this random variable X will be less than equals to 10 to the power minus 4, minus what is the probability that this X will be less than equals to -2 into 10 to the power minus 4. So exactly what we are doing, we are finding out the entire probability right from -infinity to 10 to the power minus 4. And then we are subtracting the probability that what is the probability that the voltage will be less than -2 into 10 to the power minus 4. So if we do that, we will be left with the probability in between these two range. Okay, so this probability we have to find out ultimately, right? So again, we have to use the same formula. Okay, so here I have already written this formula. So this formula we have to use. Okay, so if we use this particular formula, what we have to write is we can get this particular expression, right? So we have to write this 1 minus q function. So this will be 10 to the power minus 4 minus 0 divided by 10 to the power minus 4. And again, this minus sign. And then again, we have to write 1 minus q function. So this minus sign will become plus, okay? So again, we have to write here this value q -2 into 10 to the power minus 4 minus 0 divided by 10 to the power minus 4. Okay, so if we do that, here you can see if you solve this expression, you will be getting this simple expression. Okay, so it is 1. Here you can see this +1 and -1 will be cancelled out. And here I am going to get minus q1, and here I am going to get q -2. Okay, so you please recall that I have already explained that q minus y is equals to 1 minus qy. Okay, so this is one of the property of your Q function that I have already discussed. So if you use this particular property, we can rewrite this expression in this form. This will become minus Q1. This will become 1 minus Q2, right? So here this Q2 value is given, right? So that we can substitute. And if we substitute this value here, okay, this will become a minus 0.1586 plus 1 minus 0.02275. So ultimately, you will be getting this result 0.81865. So this way, we can calculate this third probability. And now in the fourth probability, you see here it is mentioned, and given that the value of the noise is positive, okay, given that the value of the noise is positive, what is the probability that it exceeds 10 to the power minus 4, okay? So here one thing which is mentioned is we have to calculate a conditional probability. So what is the condition? It is condition is given that let us suppose that uh, the noise voltage is known to be positive, right? So it is already mentioned it is a positive value. Then what is the probability that it will be exceeding 10 to the power minus 4? So let us suppose that this is your level that denotes you 10 to the power minus 4 volt. And it is already given that if it is a positive voltage, then what is the probability that it will be exceeding 10 to the power minus 4? So this is the conditional probability that we have to talk about. So I have already discussed about the conditional probability, okay? So here, this is the equation, okay, the base formula that I have discussed. If we have to calculate P x given y, in that case, this probability can be calculated by using this particular base rule, in which we have to use the reverse conditional probability, or otherwise we can also use this formula. Okay, we also have the joint probability. So this joint probability equation will have pxy x comma y will be equals to pxx into py by x yx. Okay, so this is the equation for your joint probability. So normally, if we can replace this particular right hand side by this joint probability, right? So this conditional probability that we are writing over here, that can also be modified, and we can rewrite this expression in the form of conditional probability, right? So px given y can be written as pxy divided by py. So now we have to correlate this formula to this particular given problem. Okay. So the problem which is given is that it is given this that the noise voltage is positive. Okay. So it means that we have to consider that the x is actually being greater than 0. Okay, then what is the probability that will x will exceed 10 to the power minus 4? This is what we have to find out. So exactly what we have to find out is we have to find out this particular probability. So what probability we have to find out? That the x will be greater than 10 to the power minus 4, given that capital X is greater than 0. Okay, so this is the exact probability that we are interested in, right? So here we have to use this conditional probability formula. Okay, this particular formula, and here we have to write this joint probability equation. So we have to write this, what is the probability that this x will be greater than 10 to the power minus 4, comma, x will be greater than 0. Divided by, we have to write this particular probability. So this probability will be same as probability of getting x greater than 0, right? So this is what we have to find out, okay? So here now you try to understand, if we want to calculate this joint probability, that what is the probability that this x will be simultaneously greater than 10 to the power minus 4, and as well as it will be x greater than 0. Then you please try to see, if you see this is the probability, this particular area will be giving you the probability, the entire area will be giving you probability that the noise voltage will be greater than 0. Okay. But if noise voltage is greater than 0, it doesn't mean that simultaneously it will be also greater than 10 to the power minus 4, right? So here you can see this blue shaded curve. Okay, so this particular section represents you, let us say this capital X, this particular X represents you 10 to the power minus 4 volt. Okay, so when this represents 10 to the power minus 4 volt, then this particular shaded area represents the probability that the x will be greater than 10 to the power minus 4. So to this particular joint probability to be true, this shaded section only will be considered, because this shaded section is actually greater than x is greater than 0, as well as it is greater than 10 to the power minus 4. Therefore, only if we write the probability of having 10 to the power that x is greater than 10 to the power minus 4, then we can satisfy both the conditions, right? Because it is a joint probability, right? So we cannot calculate only this probability, because if we calculate what is the probability that x is greater than 0, in that case, this probability will not satisfied, okay? So if we write only this probability, then this probability will automatically satisfied, right? So only this section will give you the joint probability. So therefore, what we can do is we can write these probabilities, fine? So this equation can be transformed into this particular equation. What is the probability that this x will be greater than 10 to the power minus 4 divided by what is the probability that x will be greater than 0, okay? So again, you can use this formula, right? This particular equation you can use. So if we use this expression in the denominator, in the numerator, we are going to get the q1, and in the denominator, we are going to get this as a q0, right? So I have already explained the value of Q0 is equals to half. Okay. So that we can also understand from this curve only, because what is the probability that this x is greater than 0? So then we have to calculate the area of this half of the curve. Okay. Half of the PDF curve, right? So this area will be, because we know that the entire area of your PDF curve is equals to unity. So if we calculate the area of half of the curve, okay, right half of the curve, then it will be equals to 1 by 2. So therefore, ultimately here, if you use this formula, okay, then you will be getting this as q1, and this value, this probability you are going to get is q0. Because here we have to substitute x equals to 0 and m is already 0. And if you substitute 0 divided by sigma, you are going to get q0, right? So these probabilities is already known. Q1 is already given over here, and q0 is known to be 0.5. Okay. So if we do this calculation, we are going to get this probability. Okay. This probability, this conditional probability we are going to get is 0.3172. So I hope you must have understood this problem. So if you have any difficulty, let me know with your comments. So I will be discussing some other topics in some other lectures. So thank you for watching this video.